In this clip, I want to show you how to solve a redundant frame by exploding it. So the frame that we're dealing with looks very simple. However, we have a pin at A, which means that we're expecting to have both a y component of the force and an x component of the force, and we also have a pin at point B, which means another vertical component for B and another horizontal component for B. If you look at all this, this means that you're dealing with a problem that has actually 4 unknowns, and you know that for structures in general, we are dealing with only 3 equations. So we're in trouble. In order to solve this, we will really need to explode the structure in order to be able to gain more equations and find the values that we're looking for. To find the values, we will follow the 4 steps described in here. First, adding the support reactions, which we already did. The second step will be to explode the structure, and once we've done this, it will be important to just think and see how we can solve the problem before finally verifying the answer. So to explode the structure here, we have 2 members, member ACD and member CEB, that we need to separate along the joints that we have at C. So what it will look like is just something like this, where we have the 2 members that are there. The first thing to do, once we have these separated, is to guess and add reactions at each of the joint and external supports. So we already have the support reactions, which we can add again in here. So there's the AY as well as the AX. Just guessing directions in here, BY and BX. We already have some external forces, so at D we know that there is a force of 20 kips, so 20 kilopounds, that is pointing straight downwards, so 20 kip in here. At E we have a force of 12 kip that is pointing straight down, and you see that there's also a force of 8 kips at C. That force, it's not clear where we should put it. Okay, should it be on the member on the left or the member on the right? We don't have enough information to be able to decide on this. So really it's just about picking one and sticking to it. What this means, however, is the value of C that we would obtain would depend on where we decided to put the 8 kip. Okay, so we basically cannot solve for C, but we can solve for A and B. So at C I will just add the arrow in green. So let's say that it's pointing down on the member that is on the left, so we would have CY this way, and let's say CX this way. And because of Newton's third law, when I draw it on the other member, it has to be in the opposite direction. So we would have same value of CX, but pointing to the left this time, and CY would be pointing up. Again, these are guesses. If they are wrong, just means that you will get a negative value afterwards in your answer. So that was step 2, to explode the structure and add all the different forces components. The next thing would be to try to solve the problem. Okay, so it's important before you do to start by thinking about what's going on. Okay, if you do remember that we have 3 pieces that we can use, either the full structure or each of the member. So if you think about the full structure, if you use an equation on the y-axis, you will have AY and BY. On the x-axis, you'll have AX and BX. And whenever you try to use a moment this time, because A and B are not at the same height, both the BX and the BY components or the AX and the AY component would be included in your equation. So there's no way to have an equation with only one unknown. And the same will be true if you look at each of the 2 members in here. You will always be stuck with 2 unknowns. So what you want to do is to make the most of it. So your goal, or the easiest path forward, would be to find 2 equations that would have the same 2 unknowns. Okay, so try to think about this 1 second, put it on pause if needed, and then come back so that we can look at it. All right, I hope you have a solution. Okay, so here's what I think is the fastest. What I'll do is I'll try to focus on 2 unknowns, and these 2 unknowns will be BX and BY. Alternatively, I could have chosen just as well AX and AY. Okay. The reason I want BX and BY is that I will be able to find 2 equations that will involve them. My first equation will be the sum of the moments around point A for the whole structure. And then my second equation would be the sum of moment around point C, but just for members CEB. And by doing this, in both of these equations, the only unknowns will be Bx and By. So I'll have a system of two equations with two unknowns that I will be able to solve in order to find their values. So in order to speed up the process a little bit, I already wrote these equations. So the first equation, when we look at the full structure, gives us this. So I have 20 kip force that is acting, taking the pivot around point A, that is acting at with a moment arm of 3 feet. Then there's the 8 kips that is acting with a moment arm of 3 feet again. But this one is trying to rotate the structure counterclockwise, therefore it has a positive sign. Then if we focus on the 12 kilonewton kips force, it's acting with a moment arm of 7 feet, and it's trying to rotate everything clockwise, therefore negative sign in front. And finally there's By that is acting with a moment arm of 10 feet, and that is basically positive because it's trying to rotate everything counterclockwise. And finally the Bx that we cannot forget, that is acting with a moment arm of 2 feet, and that is also trying to rotate everything counterclockwise, so positive. So all of this adds up to 0, and once you do the math, what you will get is that 60 is equal to 5 times By plus Bx. And here, small typo, that should be 2 feet, not 3 feet, sorry. We will label this equation I. Then we want to do exactly the same thing, but focusing just on members CEB. And when we do so, we'll have that the sum of moments, this time I'm taking my pivot around point C, and therefore there's the 12 kip force that is acting at a distance of 2 feet from point C. Then there is the By, which will have a moment arm of 5 feet, and the Bx also has a moment arm of 5 feet from point C. So this is our second equation, and this equation, once we reduce it, will simply give us 24 is equal to 5 By plus 5 Bx. And this is equation number 2. So our goal is to solve basically the system equation. An easy thing to do is to simply do equation 1 minus equation 2. And if we do this, the y component will simply disappear. So by doing this, we look at 60 minus 24 will be equal to 5 By plus Bx minus 5 By minus 5 Bx, and all of this will give us a simple equation, which will be that 36 is equal to minus 4 Bx, which gives us that Bx is equal to minus 9 kips. Alright, so this is our first value. We have our Bx, and from this value of Bx, we can now plug it back in the equation to get the value of By. So reusing equation 1, we can just plug the values in, and what we will find is 60 is equal to 5 By minus 9 kips. So what we get from this, once you do the math, is just that By will be equal to 13.8 kips. Okay, so now we have both Bx and By, and we can try to find out what will be the value of Ax and Ay. To do so, I think the simplest way is to go back to the whole structure and just use the sum of forces on the x-axis and the sum of forces on the y-axis. So if we do the sum of forces on the x-axis for the whole structure, we know that this will be equal to 0, and this will be equal to Ax minus 8 kips plus Bx. Alright, and the Bx we found was just equal to minus 9 kips. So we'll have Ax minus 8 kips plus minus 9 kips, and all of that has to be equal to 0, which will give us a value of AX to be equal to 17 kips. And finally, we can reuse the last equation, sum of force on the y-axis is equal to 0. So for this one, we'll have AY minus 20 kips minus 12 kips plus BY is equal to 0. So this means that 0 is equal to AY minus 20 kips minus 12 kips plus 13.8 kips. And once you solve this, you will find that AY is equal to, a bit of math in here, so we have 32 minus 13, which means 19, so 18.2 kips, I believe. Let me verify. Yes, that sounds right. So we now have all our components that we were looking for. We have BX, BY, as well as AX and AY. You see that we never had to actually find the value at C, so that's basically where the 8 kips is actually situated on which member does not matter in our final answer. Okay, so this question is not super difficult. What's tough is you have to think a little bit before you plug the numbers in or find the right equations to solve. But once you do, it's not that difficult. You could always try to write an equation, let's say for the sum of moments on the member that is on the left, and make sure that your equation would indeed get 0. So that would be a nice way to check that your numbers actually work. All right, I hope this helped.